Welcome, Heather, and welcome, Dawson, to the penultimate webinar, week 10 webinar for this Math 159 class. And let me talk about the plan of the day.
This must be a special one since there's only two of us.
I know. Do you know what's going on?
I don't know.
It's not like the weather's weird and no one has internet or anything that I know of. For me, my life has been tough today. After this, I'll have had 9 hours of leading webinars. Just to give you an idea.
9 hours of what?
Of leading webinars on Zoom.
Oh, yikes.
Yeah, because I gave a workshop on statistics, teaching statistics with online resources and free resources. So welcome, Ashley. Thanks for coming. Let me tell you the plan today. I don't think today's one of the harder days, which is nice. Kind of comes and goes. So we'll start out with the slope of the line, which is kind of a review. We kind of did that last time too. We'll do it in a little bit different way, and we'll find the y-intercept also of a line. So we'll do that looking at points. And then we'll look at the equation of a line. And then what we'll do is we'll find the predicted value if we know the equation. And then we'll get into finding the residual. The interesting thing is that I just a couple hours ago, I finished teaching the statistics class that I teach. Of course, everything's online now. And this is exactly what we did. But we did it in a different framework. You know, instead of just learning about lines, that was kind of assumed they knew what a line was and how to get the slope and y-intercept and all that. It was more how to interpret and do full long interpretations. But it's the same stuff, chapter 12 of the textbook that you'll be doing next quarter. Okay, so you know the stuff is important. It's in what's called regression analysis. So that's kind of what we're doing, is we're setting you up to be ready for regression analysis. And then after that, we'll get into set notation. So we'll take a look at a set with some brackets and stuff, and we'll try to understand how to read it. And then we'll get into how to create set notations if you're given a sentence. So I call it language and set notation. So that is the plan today. I want to mention something, and I don't think I have gotten it. Just want to make sure the chat window's up. I want to mention something, and that is if you go in to the syllabus, because we're getting close to the end. I don't know if you've realized that. And we are the last in the universe, I think, to finish spring term. But we're getting there. We're almost there. So let me show you where we are and where we're going. So this week is slope, residuals, and sets. And that is the plan for this week. Next week, we'll have a Monday webinar. And I'll talk about Venn diagrams, complements, and unions. But I'm also going to talk about the final exam, because the final exam can be taken anytime between a week from Wednesday, a week from Wednesday, I think it is, and the following Wednesday. Might be a week from Thursday, something like that. So the idea is next Monday, so 6 days from today, will be the last webinar of the quarter. So we're seeing the light at the end of the tunnel. We're almost done. And then the hope is after you take the final exam, you don't forget everything, because then you're going to take statistics and then use all this stuff is the idea. So if you look at the assignment schedule, we have this week's assignment, we have next week's assignment, and that's it. And then the final. Okay, and again, the final must be taken by the 24th, but you have from the 18th to the 24th to take it. And it's a 2-hour final exam. Very similar to the midterm in terms of what the final is going to be like. I like to get you ready, especially when we're getting to the end, talking about what's going on and how to plan and be ready. Are there any questions at all about anything? This is a great time to ask. Any questions? Okay, if there are no questions, then I think I'm going to do some examples. And I'm going to talk about slope of a line. And I think I want to start with pictures. I think it's a good idea. And we've talked about slope a little bit, but let's do some more. So let me insert a drawing. And let's suppose that we have X and Y axes. And I'll do my best. It's not easy to draw, but I'll do my best on drawing. I could just copy and paste, but I think it's good to kind of see how drawing looks, so you don't, so you get the idea slowly how you would draw a line. And so we have some axes. I'm not going to do too much of it. Tilted. And that's the x-axis. And then we have the y-axis. This is y. And move it up a little bit. Four, 3, 2, and 1. And let's suppose we have a bunch of points. So let's suppose we have that guy and won't let me just a minute. Let's try that. That one, and let's draw a line. Like so. And I could put some more points if we need, but you don't have to have more points, but I think it's a good idea because you're going to see more. So this is what kind of regression analysis looks like, is you have a bunch of points, and then you have a line that's a best fit of those points. And what we want to do is we want to understand that line. There we go. Okay, so here's a line I drew. And the first question is, what is the slope of this line? Any questions on the question? Okay, so again, everything is a review from your life. Doesn't mean you remember it, but some of you might. And so the question I've got is, if we've got a picture like that and we want to find the slope, what's a strategy for finding the slope? You can pop in the chat box, you can talk about it. Again, it's been a while for most of you. You've all seen it, but you might have been in 9th grade for all I know. Okay, look at X first. All right, so something about x. So here's one thought. So how many points do you need to get the equation of a line? How many points do you need? Yeah, we need 2 points for a line. Okay, that's something hopefully you might remember. So you need 2 points for a line. And the first thing is the equation of a line, and I'm going to write it differently than you're used to. And that's because I want to write it in the statistics way of writing it. I also want to write it pretty. So it's y is equal to a plus bx. I know you're used to mx plus b, but I want to write that way because that's how they write it in statistics. So sorry if you don't like it, but just the way it is. It's not, me being mean. So if you remember, the number in front of the x is slope. And the slope is the rise over run. So let's write this down. And you might remember that. Hopefully you do. I'll put it here. So what we want to do is we want to start at a point and we want to get to the other point. And this particular example goes through the axes. So those are definitely the points. It's the points we've got. So if we start here and we want to get here, what's the rise? How far up do we have to go? And that's kind of tricky. So if you want to start on the left point and you want to get to the right point, how far up do you have to go? What can you say? Okay, you're saying 4. Remember, I told you it was tricky. The answer is -4 because you have to go down, not up. Does that make sense? We start on the left, you want to get to the right. You're not going up, you're going down. That means you have to go -4 to get to the second point. So in terms of the rise or run, again, it's going to be a fraction. The numerator will be the rise, and the numerator will be -4. How far do you have to run to the right to get to this point? 3. Okay? And that's the denominator. The denominator will always be positive, but the numerator could definitely be negative. Let's make that bigger. Fractions never look so good in this. That's better. Any questions at all on finding the slope, which is -4/3? Any questions on that? Okay. The next thing we want to find is the y-intercept. So this particular example is pretty easy. What's the y-intercept for this one? Yeah, this one's 4 because it crosses the y-axis at 4. So the y-intercept is 4. So now we can put all this together and say, what is the equation of this line? And the idea is I've already written down the general equation. Now we just got to put it together. And you can say y equals and what's it equal to? So what can you do? Maybe you can pop in the chat box, putting it into the equation, all the work we just did. Yeah, it's going to be 4 minus, and then the b, so the a is going to be 4, the b is going to be -4/3, and that's why it's minus instead of plus. You could write plus minus, but minus is probably prettier. And then and we have 4/3 x. Any questions at all on coming up with the equation of the line that is shown in this picture? Just a note, this is going to be a lot, it's going to look like this a lot, often, not always, but often on the homework. Why are there all these points that aren't even on the line? Any thoughts? Any ideas? Why did I do that to you? It wasn't just be mean, by the way. I don't see you all jumping in, but maybe you'll have an idea. Any thoughts? Yeah, the rest of the data. So the idea is in statistics, what's going to happen is you're going to have a bunch of data values, and you're going to have a line that is the best fitting line to those points. Okay, and the idea is that line has an equation, and if you happen to know 2 points it goes through, then you can find the equation. If you don't, you're going to use a computer to find the equation, and that will do it. And I think I did that in the Q&A forum earlier, is that there's some regression line findings that happen. And there are lots and lots and lots of different programs that do that. Any questions on that? Okay, so that's the idea. Let me do it. So that's what from a picture. Now let's do it from data. So let me draw a table. That's probably good. And let's give you some data. Okay, so here's data. This might have come from some, example. I'll let you know the data I showed today in my stats class, kind of bigger, uglier numbers, so I'm not doing that now, is we looked at year versus depth of clarity of Lake Tahoe, how far you can see down. And kind of similar, but I wanted kind of nicer numbers, that's all. Okay, so here's data. And what we want to do is we want to find the equation of the line. That these points lie on. Any questions on the idea here? All right. So again,
Why did you? You need.
Luna, come. Here, you talk to him. Oh, you on a webinar?
It's not working. I didn't see him.
You gotta go, right?
No.
Nah.
He's watching you on the phone.
It's just not.
so what do we know? How do we find the equation of the line that these points lie on? Any thoughts? What was the first thing we did last time when we looked at a line, except, from a picture? Now we have data instead. We could draw the picture, but you don't have to. Okay. Enter in the calculator, but you don't have to do that either. The average, I'm looking for a different word. The hint is the same word that we used in the last example. The mean, yeah. Starts with an S. Slope. So you're going to find the slope of this line. Okay, and these points, unlike the picture that I showed you before, these points all lie on the same line. So we could pick any 2 points you want. I'm just going to pick the first 2 points. And let me just write them down. The first 2 points are 5, comma, -2, and 7, comma, -5. Did I lose anyone there? So how do we find the slope of the line that goes through these 2 points? Any ideas? Any thoughts? Yeah, the rise over the run. So the rise is a difference in the y values. So that's going to be -5 minus -2. What's -5 minus -2? And we had a section on this where we talked about how do you subtract sign numbers. Okay, I'm still waiting for the right answer. I can see where your errors were. There we go. Yeah, -3. So remember, that's the same thing as -5 plus 2, because when you have 2 minuses, that makes a plus. And that's equal to -3. Again, you can use a calculator, but this isn't supposed to be that hard. But you just have to pay attention to the negative signs. How about the run? Well, the run is going to be the difference in the x values. And that's going to be 7 minus 5. Yeah, and that's a 2. Any questions on that? So now, what is the slope? The hint is the fraction. Good. The slope is -3/2. Any questions on that? Okay, so we just found the slope. So now what we're going to do is we're going to say, well, let's look at the equation. The equation, if you remember, let's just review that, is y equals a plus bx. Any questions on that? So now what we can do is I can use either any point I want, because they all lie on the line, is what I told you. So I think I'm going to use just 5, -2. Those seems to be the smallest, easiest numbers. And I could say y is -2 equals a, which I don't know, and then plus, and then b is the slope, which is -3/2. Times x, and x was 5. Any questions on that? Okay, we're getting there. How do I get a by itself? Any ideas? I want a. So how do I get a? Divide by 5. That actually won't do it. Notice a is an a plus. Do you see that? So I need to undo a plus. How do you undo a plus? How do you undo addition? Right, because we can see this plus. Yeah, I subtract, and I'm subtracting -3/2 times 5, which is the same as adding 3/2 times 5. So I'm going to add 3/2 times 5 to both sides. So you get -2 plus And by the way, 3 halves times 5 is 15 halves. Because 3 times 5 is 15. So now I can simplify. -2 is -4 halves. -4 plus 15 is 11. So we get is A equals 11 over 2. Oops, I'm already in. And now I can put it all together. So now what I'm going to do, I think I'll copy and paste because that way we can go with what the equation is. We know y is supposed to be a plus bx. So I'm going to take the a, which is 11 halves, and replace a with 11 halves. And then b was -3 halves. So plus bx makes it a minus 3 halves x. So let me ask you, I did a lot of stuff here. Did I lose anyone?
Yeah, what happened to the negative sign from the -3/2? When you added it to the other side, does it lose its negative? Because you added it?
So exactly. So what I'm doing is I'm not adding and I'm subtracting, right?
Okay.
And subtracting a negative is the same as adding. Does that make sense?
Yeah, I just want to make a note.
Huh?
I just wanted to make a note so later on I can realize.
Yeah, if you want to get rid of a negative, that means you got to add. Does that make sense?
Yeah.
And that's what's going on is to get rid of that negative, I need to add it. And then if you take -3 halves over -3 halves times 5, and you add 3 halves times 5, you get 0. Because a negative plus a positive is 0 if they're the same number. Does that make sense?
Yeah.
So that's what happened is I added it instead of subtracted it. Because subtracting won't kill it. Adding it kills it. Any questions on this example? Okay, so again, notice a main thing is slope and y-intercept. And you got to remember y equals a plus bx. If you want to do mx plus b, you can, but that's not what you're going to see in statistics. So I like to show you how you're going to see it in statistics, which is this way. Okay, so don't shoot the messenger, please. All right, any questions at all on that before we move on? Okay, so what we've done already, let's go back up. Let's talk about where we are. We've talked about the slope, and we now know how to find the slope, whether you're giving it visually or whether you're giving it using points, we can find the slope. Similarly, we know how to find the y-intercept, whether you're doing it visually or with points. The equation is y equals a plus bx, and that's no problem. And then we want to find the predicted is the next question. Any questions on that? So the idea here is we have this line, okay? And what we want to do is want to use it. In fact, I'm going to do a few things. I'm going to use this line as the example because there's no reason to drop it again. And we already know the equation. So let's pop that equation at the top so we can see it. And often you don't call it y, you actually call it y hat. So I'm going to do that. That one, I think. There we go. So you call it y hat because it's a predicted value, not an actual value. And in statistics, you use hat for predicted and use y for the actual. Okay, so what we can now say is, for example, find the predicted value for x equals how about 1.6. Okay, maybe I'll do 1.6-ish is 5/3. There's a reason I'm picking that weird number. So what do we do? The answer is this isn't that hard. What do we have to do to find the predicted value for y equals 5/3? Yep, we just plug in x. Okay, so what I can do is I can go, I like to copy and paste and then replace. So there's our y hat again, and we're going to take that x and we're going to replace the x with a 5/3. Okay, and we can even say y hat of 5/3 if you want. Okay. That's not quite work, but let's see if I can do it. That's better. Okay, so now we have to do some arithmetic. What's 4/5? What's 4/3 times 5/3? What's 4/3 times 5/3? Okay, that's 20/3. And notice 4 is 12/3. So 12/3 minus 20/3 is -8/3. Any questions on that? Is that right? There's a mistake here, I think. Let's double check. Let's have 12. So I'm just double checking. It's x, we're plugging in 5/3, and that's 20 over 9. That's the problem. Sometimes I'll get tricked by the chat box. 20 over 9, does that make sense? And 4 is 36 over 9. 36 over 9 minus 20 over 9 is 16 over 9. So kind of messy fraction stuff. And there's our predicted value. Okay, now what I want to do is we're going to find the residual at x equals 5/3. Okay, now that's a word you may not have seen before, so we got to define it. So the residual is the observed minus the expected. Okay, let me show you where that comes in. I think it's worth showing you because, again, I'm throwing a lot of words at you, and I want to show you what it's going to look like on the homework. So if we go to our homework under residuals, and you'll see a residual is the distance between the observed value, observed y value from the scatter plot and the predicted y value from the equation y minus y hat. Okay, so they're going to give it to you in long words. I gave it to you shorter. but I want to kind of show you how that works. And notice the observed is the observed value from the scatter plot is what the y coordinate of the point is on the plot. And the predicted value is what the y coordinate of the line is. So let's go back and let's play around. So let's go to observed first at 5/3. You know what? I better do the following. This is not going to work the way I've got it written. Let me edit. I need to take this guy and move it a bit, or this won't be possible. Just kill it. There we go. And let's put a new one in. There we go. So far, it doesn't affect anything we've done, but now it will. Okay, so now what we're going to do is we need to find the observed value at 5/3. So now we're going to go to the graph, and we're going to find 5/3. Notice 5/3 is less than 2, greater than 1, right? It's kind of on the 2 side, and there's your point right here for the observed value. So the observed value is where the point is. And what is its y coordinate about? What's the y coordinate of that point? Yeah, it's around 3. And I'm going to let 3 be good enough. So if we want the observed, then that's going to be equal to 3. And then we're going to subtract the expected. Okay, the expected value is what we just calculated over here, 16/9. Any questions on how I got those two numbers? Any questions? Okay, and if you work this out either with a computer or by hand, notice 3 is 27/9. 27 minus 16 is 11. So what you get when you work this out is 11/9.
I have a question on the y hat up there. Why did you put the 5/3 next to it? Is it just to get rid of
which 5/3? This one?
Yep.
That's just notation. So the way you read that is y hat when x is 5/3.
Okay.
It's not a multiplication. That's called function notation. You won't have to do that. I was just being, rigorous, I guess, the way people do it. This is the way people do it.
Okay.
So they say it's y hat of 5/3. So it's, what is y hat when x is 5/3? It's just shorthand for saying that. Does that help?
Yeah.
Okay, yeah. So don't worry too much about that. More importantly is you know how to plug in 5/3 and then do the arithmetic. And that for residuals, when it says observed minus expected, that means the observed, you have to go and find the point and look for its y value. And the expected, you have to have that y hat of what, you have to plug in the value of x into the equation, subtract, and that'll give you the residual. Any questions on that? Okay, it's a lot of little things. Nothing that hard when you do it, though. I promise it. It's really not that bad. It's just there's some terminology that you got to deal with.
And then the 3 you got from that tape, the image right there, the picture.
Yeah, so what we did is we said, well, X is 5/3. We went to the picture. 5/3 is about there. And notice there's a point above that, right?
Okay,
And look at its Y coordinate, and that's about 3.
okay,
Had you got 2.9, that might have been even more precise, but 3 is good enough.
okay. Sounds good.
Okay, yeah, so it's the Y coordinate of the point at that X value. Okay, good questions, really good questions, real important. And that's kind of the whole point of these webinars, is to be able to ask questions and get quick answers. So if you just watch a video, then you don't get any answers. If you ask the video, it doesn't do anything. Okay, any other questions about this example? Okay, now let's do an easier one. Find the residual. Actually, this one won't work so well because that's not a true scatter plot. So let's do another example, but I want to do one with table looking stuff. So I'm going to get a table again. How about 4 points is good enough? And let's say you have 3, 7, 5, 8, 6, 8, and 9, 10. Okay, now what I'm going to do just for fun, I'm going to show you what it looks like in a stats class. This is what I did today in my stats class, so can't hurt to watch it. So this is a regression analysis calculator. And if I have the points, I have 3, 7, then 5, 8, so 3, 7, plot the point, and then 5, and then 8, plot the point. Okay, and then we had 6, 8, and 9, 10. Plot the point, and then 9, 10. Okay, and we have a regression line. Okay, the regression equation is that guy. So I can actually copy it and paste it into the question. Figured I'd show you how to find the equation using the calculator I created. Okay, so now is find the residual at x equals 5. Okay, and let me write down, make this equation. And then I want y hat. There we go, just to make it prettier. Okay, so you want to find the residual at x equals 5. Okay, so what is the observed? And that's the hint, it is very easy. What's the observed value here when x is 5? Yeah, it's 8. Because if x is 5, y is 8. Then what is the y hat value, or the expected? And that one's a little messier, but not impossible. I'm going to copy and paste. And then I'm going to go of 5. And that says I better put a 5 in for x. Any questions on that? And then I need this in a calculator. So I'm going to pop it in the Google calculator. And you get 7.8798. And I need to make a new page. There we go. And that made it a little too big. Okay, any questions on that? So how do I find the residual? Yeah, we go O minus E, but in particular, it's 8 minus 7.8798. Which is equal to 0. Let me do it in my head. 1202, I believe. I think that works. Yeah. And there's our residual. You could use a calculator if you want to. Have I lost anyone on the residual calculation? By the way, what's the slope of the regression line? The hint is it's easy. Yeah, 0.4933. And what's the y-intercept? Also easy. Yep, 5.4133. That's all there is to it. Any questions at all on this whole lines and slopes and residuals and expected and observed? It's a lot of words. Any questions on any of this stuff? Okay, now that we've got that, let's move on to a totally different section, and that is sets. So let's suppose we have this guy. You know what, I have to do it as an equation. So set of all x. Okay, so the first thing is, how do you read that? What does it mean to say that? I don't know how to read this notation. And this is standard notation, by the way. Anyone know? Okay, so the way you read this is the set of all x. And that little vertical line segment is read such that. And now it's 4 is less than x, and which is less than or equal to 7. Any questions on how to read this set notation? Any questions on this? Okay. We did this a long time ago, and I figured I better do it again just because it's been a while, and you have a final exam coming that does test you on a long time ago stuff, is that we should be able to do this on a number line. Remember doing this? So if I go and insert a drawing, we can make a number line out of this. And we need our numbers. Four through 7. So 4, 5, 6, and 7. And let me remind you that we're trying to do the set of all x such that 4 is less than x is less than or equal to 7. Just to remind you. So how do we draw that number line? Do you remember? What do you put at 4 and what do you put at 7? Remember, it's been a while. Yeah, open dog. Usually call it dot, but you could do dog if you want. Open dog at 4. So we're going to do an open circle at 4. And we don't want it filled. And then we want a closed circle at 7. And this one we do want filled. And then what we're going to do is we're going to draw a line between those 2 points. And there it is. Is x supposed to be smaller than or equal to 7? Yeah, less than or equal to. I didn't have the symbol when I was doing the drawing, so I had to write less than with the equal next to it. Okay, so it's not perfect drawing, but it's all I can do on the drawing tool. Okay. And there's your graph. So I just wanted to remind you how you draw these things. If you're given a set notation, how do you draw a picture of it? And that's how I draw a picture of it. Any questions on that? All right. So that's pretty much how you do it. And that's how you read it. Just remember the main new thing is this little vertical line segment means such that. Okay, so now let us do the opposite. What if we have, consider the rule that a person must be shorter than 3 feet or taller than 7 feet to be considered. Maybe I'll make that 4 instead of 3. How about 5? To be considered an outlier. Write this in set notation. Any questions on the question? Okay, so the first thing you do is you put one of these little curly braces in. Then you put X. Then you put the little vertical line segment. And now we look at it, you must be shorter than 5 feet. How do you write that as an inequality? It's not that hard. So -5, not quite. Yeah, X is less than 5. And then you just write or. And now how do you write taller than 7 feet as an inequality? Yeah, greater than 7. So X is greater than 7. And then you always end the bracket. And that's the answer. And that's the inequality. Any questions on this idea? Okay. Just a note, a few things at least. What inequality is at least? Includes. Yeah, so in particular, at least corresponds to greater than or equal to. How about at most? What's at most? Yeah, that's less than or equal to. So you're going to need to, get used to all these to be able to answer some of the questions in the homework. You can see these kind of words. Okay, so those are the ones that kind of stumble people. Is that people think at least and they think that's small, but it's not. At least is big, and at most is small. It feels backwards, but that's the way it is. That's just English. Any questions at all on these words? Okay, so the last word of the day. Any guess?
It's a secret word.
It is a secret word. I try to end around 7 and it's 7 o'clock. And the secret word is fraction. Fraction because when you're doing the slopes, that's the fraction rise over run. So that's why I figured kind of works with it, but you probably would have never guessed it had you not watched the webinar. Okay, so that's it for what I need to say new stuff, but I'm always happy to answer any questions you might have. So if you have any questions, let me know. And if not, next week is our last webinar. It's a good one to go to because I'll be talking about the final also and material. It's a lot to talk about next week. So any questions? Okay, you two have a good night, Ashley. Any questions, Mike or Michael? And let me, I think I haven't stopped recording.